Okay, our day 7, we skipped day 6. So day 6 is a topic we're not going to worry about. It's compositions with these trig functions. We're going to throw that out this year. So if you're wondering where that went, so there is no day 6. So lesson 6, day 6 is gone. So first off, I graph these three. The left side here, we know these. So if you want to pause the video and catch up with those, graph those, you get your cosine function, your sine function, your tangent function with their domain and ranges here. So go ahead and pause it if you need to and fill those out. Otherwise, I'm gonna move on with the next thing. Now, the big thing here with like cosine, this is the inverse function. If you remember, inverses mean they literally switch the x and the y's. Okay. So now, if I switch the domain and range here, this one's domain would be from -1 to 1, and the range over here would be this one's domain, which would be -infinity to infinity. The problem with this, like when you flip it, remember you flip it about that diagonal line, it would look like something going like this. It'd be alternating back and forth, a wave going that way, which it would not be a function, okay? Because the vertical line test, it would fail it multiple times. So what we do is, in order to keep it a function, we limit it. We're going to limit the range. We're going to say, I only want to deal with from 0 to infinity. I'm sorry, infinity, from 0 to pi, which basically is, from 0 to pi is the top half of the unit circle. So if we look at this here, that's like taking this from 0 to pi. It's just taking that chunk right there, and we're going to flip it over. So this, when x was 0, y was 1. So now over here, when x is 1, we'll just say 1's right here. So this is 1, this would be -1. Then so 0, comma 1, this is 1, comma 0. Right here, I've got pi, comma -1. So over here, it's going to be -1, comma pi. So it looks something like that. And instead of going this kind of wave, it's going to look like this. It's going to come down. Almost think of it as you're coming down the wave this way. So it's going to go through right here, because 0 or pi over 2, comma 0, 0, comma pi over 2. We switch the x and the y. It's going to look something like this. Curl back around this way. So it's something like that. But we limit it, that way it passes the vertical line test, because if you kept this going, it would go like that. And it would pass it would fail at several points of vertical line test. So we basically, with cosine, we look at just the top half. I think cosine is the x-coordinate, so this kind of covers all the possible x-coordinates you could have. You could have x from -1 all the way to 1. So I can go left 1, left a half, right a half. So this basically covers all the possible x values we could have. Now with sine, same idea. If I took the range and flipped it, the domain would be -1 to 1. And if this domain was -infinity to infinity, the range would be -infinity to infinity. But again, that makes a curve that would fail several times. So what they do is, to keep it a function, we're going to limit that to -pi over 2 to pi over 2. Whoops. Okay, which is basically like taking this chunk right here. Look at that. Just look at that and reverse that. So it's going to flip it, about this diagonal. We're going to flip out all the x's and y's. So -pi over 2, -1. This will be -1. We'll say this is -1 right here, and this is +1. So this would be -1, -pi over 2. 0, 0, 0, 0. Pi over 2, 1. 1 pi over 2. And it really, think of it as the curve's going up like this, so it would come down through there and look something like that. So that's what the sine, inverse sine looks like. And for this, you're basically only looking at, you think, with the x's, the x's represent the y coordinates, so that'd be from anywhere from -1 up to 1. So we really only look at from pi over 2 is up here. This is -pi over 2. So we're only looking at the right side of the unit circle when we do this. So we're only graphing all the points on the right side of the unit circle. And for tangent, they just kind of decided. They just picked one. They looked at this and they said, well, this is the most simple. The simplest one we have is from negative pi over 2 to pi over 2. So we're going to restrict it. We're going to say that is what my range is over here. So when you flip this now, the domain on this one, if this one's range was negative infinity to infinity, this one's domain is negative infinity to infinity, and that's fine. Instead of having this kind of a domain, we're just going to look at this from negative pi over 2 to pi over 2. Okay, so if I took this guy right here and I switch it, look what happens. So at negative pi over 2, I'm at negative infinity. So I need to think negative infinity, I'm at negative, so it's somewhere over here. I don't want to put a point there, it's more of an asymptote going through there. I'm coming in through this way, 0, 0. And then at pi over 2, I'm basically at infinity. So at infinity, I'm basically at pi over 2, so it's going to come down through here and go that way. Okay, so this is just one of these flipped over. So flip out the x and the y axis and you get this. We really have these asymptotes there guiding those. So yeah, so that's, and on this one, from negative pi over 2 to pi over 2, the same thing. We're only looking at the, so for sine and for tangent, we look at the right side of the unit circle. For cosine, we only look at the top of the unit circle. Okay. So why is that helpful? Well, on the back side, we're going to do some solving, which your calculator can crank these out pretty fast. We don't want you to solely rely on your calculator, because if you type this into your calculator, okay, I've already typed it in. If I take the inverse sine 0.5235, well, that is pi over 6. If you take pi divided by 6, that's the same thing. So this gives you a decimal answer. The calculator can do it really fast, but we want to do it without the calculator. Okay. Okay. So first off, probably the fastest, easiest way is using the unit circle. And keep in mind, when it's a sine, we're going to use the right side of the unit circle. When it's a cosine, the top half, tangent, right side. Okay. So sine. Put all these in here. Also, I should mention too, inverse tangent is the same thing as arctangent. So when you see the -1 or they say arctangent, they mean the exact same thing. I have no idea why arc is in there as vocab that means inverse, but it just is. So this guy here, so sine of 1/2. So I'm going to look at just the right side over here. When does sine equal 1/2? So sine's the second coordinate right there, pi over 6. So this answer is pi over 6. Now you could do this in your head. I think sine is the y coordinate. I want the full range of y coordinates, so I'm going to look at the right side. So in order to get 1/2, that means I have to go up. So I went up 1/2, call that 1. That's a 30, 60, 90 triangle with 30 degrees on the inside. 30 degrees, the same thing as pi over 6. So you can do it without the unit circle. I understand if you want to use the unit circle to speed things up, but know the process without the unit circle. Okay. Okay, cosine, top half. Cosine is the x-coordinate. When does the x-coordinate equal 1/2? We have to go right to do it. Up there, that's pi over 3. Okay. Inverse tangent. Now remember, tangent is the sine over the cosine. So I'm trying to find, what theta would I divide these to get radical 3 over 3. If you want to unrationalize that, because it's probably easier to find things in here if it's unrationalized, this would be the same thing as 1 over radical 3. We know the unit circle, everything's over 2, so just kind of ignoring the 2's, look for where the first coordinate is radical 3 and the second one's 1. And right here, they're both over 2, but radical 3 and 1. That's one way of doing it, so this is pi over 6. Yeah, you could also draw your triangle out like we did back here and do some of the same stuff. So maybe I'll speed up here. If you want to try some of these, I think, yeah, try these. Maybe pause the video and try these. Try these out here, and then I'm just gonna write the answers in because I kind of think you get the process with those, and then I'll explain the bottom ones there. I will emphasize here I have the negatives on these. I don't want to put 11 pi over 6 because for sine, remember for sine we're using the right side of the triangle here. we want to keep our, I'm sorry, yeah, using the right side, but I don't want to use the all the way around because my range on this is from negative, remember on the front side, I can just flip this over, for sine, my range is from negative pi over 2 to pi over 2, so I have to pick an answer that's between those. So instead of going all the way around the circle and getting 11 pi over 6, I want to put negative pi over 6 because that's within my range. Okay. So on these, we do want to use, if you're in that, flipping the papers the wrong way, if you're in that fourth quadrant, use the, doing sine and tangent, if you're down here, use the negative angle, not the positive angle, going all the way around. Okay, so these guys down here, we're kind of doing 2 steps in one. Now, this is a composition of sorts. We're just not graphing them. That's what day 6 was graphing a whole bunch of compositions. So first off, for this guy, just do the inside first. So sine of, inverse sine of 1/2, or arc sine of 1/2, which we can look up over here and find it, or we already did that up here in number 1. This is pi over 6. So now I'll take the cosine of that. Well, cosine of pi over 6, and I realized that I had reversed. I had recorded when I thought I wasn't, and I wasn't recording when I thought I was. So I finished doing this thinking that it was recording me, but so I got to the pi over 6 part here. So now take cosine of pi over 6. So cosine of pi over 6 would be radical 3 over 2. That's where this guy came from. Okay, first thing here, inverse cosine of radical 2 over 2. So inverse cosine of radical 2 over 2 right here is pi over 4. So that's where I got the pi over 4 from. Now to the sine of pi over 4. So I can drop down here if I want, or I can use that. It's up to you. But pi over 4, the sine ratio is radical 2 over 2. Now, it's not common that the answer you plugged in is the answer you get, but it was on this one because that's a 45, 45, 90 triangle, so the cosine and sine ratio are the same. The cosine of pi over 3. So cosine, so here's pi over 3. The cosine is 1/2. Now take the inverse sine of 1/2. So I gotta look for where is the second coordinate 1/2. So it's right here. That's pi over 6. Okay. Well, here's the rest on the one I'll jump to is this one. This one's kind of not as explanatory, but it says sine of 7 pi over 4. Well, that's on neither one of these, but 7 pi over 4 is the same thing as negative pi over 4. So that would be negative radical 2 over 2. Now take the inverse sine of negative radical 2 over 2. Well, that's back to negative pi over 4 because inverse sine and sine literally wipe each other out. So you would think this is the answer, but that's not in my range. My range has to be from negative pi over 2 to pi over 2. So that's why it's negative pi over 4, not 7 pi over 4. And this guy here, again, if I do sine of pi over 3, so pi over 3, the sine is radical 3 over 2. Now I'll take the arc cosine of that. So I want to know when's the first coordinate, radical 3 over 2. That's down here at pi over 6. So that one's pi over 6 is your answer. So if you're in class right now, raise your hand if you have any questions. If at any time, if you're not in class, circle the ones you had trouble with and ask me when you get here.